The topic we are going to make our video about is projectile motion. Projectile motion occurs when an object is launched and only under the influence of gravity, disregarding air friction, air resistance, or propulsion. It is important to remember that in projectile motion, the horizontal and vertical components of motion are independent. Some key questions one might ask when addressing projectile motion could be, what is the relationship between the horizontal and vertical components of a projectile? At what angle will the projectile be launched the furthest if it is launched and lands at the same height? And is it possible to use projectile motion equations to accurately predict the landing point of a launched projectile? In our video, our goal will be to use the projectile motion equations to predict the landing spot of a launched projectile. We will place a jar where our results indicate the projectile will fall when launched at a 30-degree, 45-degree, and 60-degree angle. If our calculations are correct, then our projectile will land in the jar every time. The projectile should travel the furthest when launched at a 45-degree angle. The data we will calculate in order to help us predict where to place the jar will include the muzzle velocity, time aloft, and horizontal distance of the projectile in motion. We will be using a projectile launcher as well as a Nerf gun to launch our projectiles. Thanks for watching our video. Here are some important equations for figuring out projectile motion. This first equation, dy equals 1/2 at squared, helps us find out the time that the projectile is in the air when launched at 0 degrees. dy is the height at which the projectile is launched. Once we figure out what t is, we can then plug it into the muzzle velocity equation, v equals d over t. By figuring out the muzzle velocity, we know the velocity at which the projectile comes out of the projectile launcher, or the Nerf gun. By figuring out the time, we can figure out the muzzle velocity. This next equation, y of t equals dy plus v naught y times time plus 1/2 at squared, helps us figure out the time that the projectile is in the air when launched at an angle and landing at a distance different from the point it was launched. Yt gives us the height of the projectile at any point in time. dy is the initial height that the projectile is launched. v naught y is the y component of the muzzle velocity. You multiply that by time, plus 1/2 at squared. dx is the horizontal distance that the projectile travels. To find this, we use the x component of the muzzle velocity times the time that we found using this equation. By finding the horizontal distance the projectile travels, we will know at which distance away from the projectile launcher we should put our jar in order for our projectile to land in the jar.